Welcome back, Precalcsters. So today we are going to continue on. We are looking at direction angles, and the important part about this is any vector that I ever give you in two dimensions, especially in component form like this, it has an x and a y, which is just the same as thinking that I have a cosine and a sine, and I can get the tangents of it and get the angle super easy every single time. So to jump in using our direction angles from yesterday, I'm going to throw us a slightly different looking problem, but I promise it's the same idea. We're just going to express it differently. So let's say that on B, to kick us off today, we're going to start with an awesome vector, but I'm going to write it in a wonky way. I want us to think about the vector 3i, and I'm going to use hat because I do like hat more, minus, I don't know, 7j. Cool. There's our vector. I want to know two things. And I guess just one, because this is the same example. I want you to find the angle at which vector v in this situation is traveling. Cool. I have an answer.
No, it's not something.
That's okay.
Is your mic broken?
No.
Because during the videos it sounded a little scratchy.
I am certain it's from me doing this when I'm walking around, is my guess. Could you still hear it?
No, when you're right there.
When I'm here, it sounds scratchy?
It sounds like, oh, you're kind of breaking the sound very.
I will turn down the volume for the take volume. Thank you for the heads up. The number of times I recorded a video and forgot to hit record the sound and posted a video with no noise is unreal.
Oh, I just needed to finish this calculation, but I forgot that you did this like I don't even know if you still want it.
I definitely still won. This is 0.
Sorry about that.
No, it's not my grade. You're good. All right, step one, because this looks ugly. What would you guys do, or what did you do? Can we change this to component form instead? Is it hard to do? No. Now, if you don't remember how to do it, of course it's going to seem challenging. I'm just going to rewrite vector v, and I'll switch to a color to see that we're working stuff. I want to rewrite this in component form, and I don't want to have to show all the steps. All the steps entail doing this. That's actually 1, 0. And then it'd be minus 7 times 0, 1. That's what j is. But I think you can probably do this in your head. What does this shake out to in the end? 3, negative 7. Is it reasonable to expect that maybe you don't have to show all this? Because it's just right there already, right? The second we get this, we are golden. I have a vector that starts at the origin. It goes right 3 and down 7. Which quadrant did I just end in? I ended in quadrant 4. So here we go. If you want to sketch it, you can. Over 3, down 7. There's my 3 and down 7. And here's the vector v that we're talking about. I'm trying to find this angle. Now, I make sense of where I'm working as far as the coordinate plane is concerned, because when we do the calculation, we might get something a little bit different. From this triangle, if I want to find theta, or if I have opposite and adjacent, which function could I use? And then I have to undo it, so I'll use the arctangent. So the arctangent of, what's opposite of theta, or the y value? Negative 7 over 3. Okay, do me a favor real quick. Let's get an approximation. We're going to make sense of it. I know I'm more than 45. And I'm not sure what your calculators are going to spit out, so I'm real curious to see.
Oh, wait, radian?
I would put it in degrees probably if I were doing this.
I just don't understand the I and the J. Like, I know that we did that yesterday.
So all they are is it's a way to write any vector as the sum of two more vectors, which is an important idea to make what's called a group in mathematics. Vectors make a group. That's the big takeaway. Your book stresses this, although for our class we don't need to. I just want to make sure that when you see the problems like this, I is just a vector 1, 0,
And J is
and J is just 0, 1, always. Okay, what angle? Do we get negative? Okay, so it worked out really nice. Is it exactly 66? 0.8. Okay, I'm going to keep it there. Now, does a negative make sense here? It should. Hypothetically, if we had just switched the signs, and I'm going to try, I want you guys to do this as well. This is not our problem, so don't draw this. But if I had gone over -3 and down 7 instead, if we did the tangent of this one and found this angle, what is it? Well, let's check, because I want to make sure that we can clear this up on the calculator and make sure that we're cool with it. Did it give you 246? Okay, will you just ask the arctangent of 7 over -3? Like, it's going to be the same number, right? Nope. So here's the weird part. You're still going to get -66 on this one, right? And you were right, whoever here said it. But here's the issue. Is that really -66 degrees? No. How would you express what this is? If it were in quadrant 3, like 66.8, that number itself is okay. But that's not really the direction that that vector's going, is it? How would you do it? So, if we add 180, careful. If we add 180, we'd get a positive what? Is this 127 degrees from here to here? Do you see what I'm getting at? Why we have to be able to make sense of it? So, there's a few different ways that I would do it. It comes out as negative because we're in quadrant 3. Do you guys agree that the real angle is just positive, though? And then now, what is the obvious thing that we would add if we were drawing a quadrant 3? Now we can add our 180. Be really careful. The way that they combine with the negatives and stuff can get weird. As long as you're aware of where you're at, we can sort it out. Cool. All right. I think I am cool with where we're at currently. And let's... What's up? Okay. All right. So, welcome to application day. So, figuratively, I want you to put on your vector hats real quick. Or physics hats. And here we go. So, I'm going to use a little editing magic so that people here don't have to wait awkwardly and watch me write it down. Before continuing, questions about anything that we've done or where we're at here? Go ahead. I think you misunderstood the question. Do you have questions? No. Okay. That's where we're off. Correct. Yep. Or you just give me the bearings, and it would be weird in this one, and it's weird bearing to do it, but there's always a bunch of ways you can write an angle. If I got this one, whoa, where was I? Right here. I already erased a picture, but I know that that's -66 from west. So we could say west, 66.8 degrees to the south. Like, and you could do it a bunch of different ways. Standard position is always the easiest, where we just go from the positive x-axis. Okay. All right. So a little editing magic. Here we go. Ah! So here's our first one. There's nothing crazy going on. We can probably sketch it out. Now, this is where that linear combination idea comes in fairly convenient, but we don't have to expand it out all the way. As we're looking at this, I know that for each component, we can separate it into, for any vector, we can separate it into its components. To get the x component, I'm going to use a trig function. That's which trig function? Which trig function do we associate with x values? Cosine is x, right? Sine is y. So if we're looking at this, I don't need you to sketch it unless you really want to. I'll sketch it just in case we need it. But check it out. Here I am. I start at south and I go 65 degrees west. First thing I care about, if we're going to do trig stuff, this is the angle that I worry, or that I need. What's that big red angle? So that was 65. So it's 180 plus 65, right? 245. Everybody cool with that? So I'm just going to make a little note. Real theta here equals 245 degrees. Nothing crazy happening, I don't think. Okay, so check it out. Do we have a magnitude of our vector? You know how long it is? So, and that's why I love this question. You say no, Bea, because I don't give you a direct length, but a magnitude is just a size. It's the velocity, it's 135. So check it out. We know that the magnitude of my velocity is 135. Now, and that's miles per hour, I suppose. As we go through here, we are trying to blend the physics and the pre-calc and the approach that we take in each because they're similar but a little different. As we look here, do you guys ever remember seeing r cos theta and r sine theta? Where r was the radius, right? Is there a circle that does exist around this that we just don't draw? Then is 135 a radius of that circle? So check it out. I'm going to write one extra step that's uglier than what we truly need because we would be able to get there. I know that the magnitude, and we're just going to write vector v out of this, is 135, and then I know for a fact that I'm just going in the x direction, whatever the cosine of 245 is. And in the y direction, what's the trig function that we associate with y? Sine of 245 degrees. Okay, we could sneak in some i's and j's, but we don't need them. They are there. They're just working behind the scenes. We don't even have to really think about it. Could we calculate this out? Pretty doably. Okay, now I have no idea what the actual number is, but let's check it out. This vector, when we distribute 135 times cos of 245, what do you guys get? And I'm going to change one thing, but we're not going to change a problem because we have a mistake, but we're going to find it. Because as I'm dealing with this, and we don't have to necessarily think about it as a radius, but could I make this a right triangle? And then this would be the hypotenuse, right? So if you'd rather think in terms of opposites, adjacents, and hypotenuse, we could. But because we're in Precalc specifically, I could also imagine there's a circle around it, and this is the radius. Yep, either way works. Okay, with this, what do we get 135 cos 245? 137? Negative 57, okay. Thank you. And any decimals? 0.1. Okay, and the other one? Do you guys second this?
Oh, no, 0.2. 0.4.
Okay, now do you second it? Okay, so with this, what does this represent? That's the velocity of this thing in the x direction. And what does this represent? The velocity in the y direction. Okay, now it's time to identify the mistake that we've made. And I kind of led us into. We said it's start at south and turn 65 degrees west, right? We're not going to change a problem. We're going to change what we wrote down. Did I put the 65 in the right spot? It should have been here. Now, we're not going to change the whole problem. We're just going to fix it. Instead of saying 65 degrees west, what would this angle have been? We're just going to say that that was 25 degrees west to south so that we don't have to redo the whole problem. Okay, that's my bad. That was a typo. Didn't even catch it. Doable. Feels like physics, kind of. If we called it momentum, it would feel a lot like physics. Okay, should we bump it up a little bit? Good. All right, a little more editing. No jump scare this time, probably. So here's our problem. Now, if wind is blowing against a plane, will it impact the course of the plane?
Surely.
For sure. Now, maybe it's minute and it's not huge, but it will impact it. So we want to be able to make sense of this. How many velocities are we considering? Two of them, right? We have a plane and we have wind. So we're going to make sure that we assign some variables. So I'm just going to call them VP equals what? Okay, so everybody except JV sees us do this regularly. Why sub P, sorry, JV and Charles. Why sub P, do you think? What's flying? So I'm going to ask again, why v sub p? The velocity of the plane. Cool. What else should I have? V sub w seems reasonable for the wind, and it's 40 miles per hour. Okay. Now, if we wanted to be really specific about this, we could add these, because these are magnitudes. These are the size of the vector, the length of that vector, if you will. I think it looks starting to get kind of ugly when we do this with everything, but this is really and truly correct. Anything else worth having? Let's get the angles. What's theta sub p? 300 degrees. And what's theta sub w? Be real careful. You say 60, why? North, and then you turn this way east, and that's 30. It means this must be 60, right? Okay, 60 degrees. Now the cool thing is that these are both really nice numbers on the unit circle, so maybe we don't even need calculators. Okay, so now what? We have all of that worked out. We have some variables picked. Does this have an x and a y part? So not a lot of confidence in there. Check it out. We have a plane. You don't need to draw it. Here's roughly 300 degrees, right? Does this 300 degrees that we've gone right here have an x and a y? Cool. Can we find their components then? So let's do that. So if I wanted to write vector v sub p for my plane, I think we can sort it out. What's the magnitude? So here's our magnitude out front times the cosine for x of 300. Cool. Degrees. And what's the y coordinate? The sine of 300 degrees. Cool. So here's my components I'm going to be able to get out. This is the plane in the x direction. This is the plane in the y direction. Can we do the same thing with the wind? Okay. What's the magnitude of the wind? 40 miles per hour. And cosine of 60 degrees. And sine of 60 degrees. Now, this is super handy, and I see people typing it in already. What is the cosine of 60 degrees? I'm up here. 1/2. That is a piece of cake. I don't need a calculator for this first part. Okay, but we want to know, how do these things impact each other, right? Go ahead.
No, you do. I will figure it out. It's my honest God.
Okay, I'll check in. As we look at this, they both have x's, and they're going to combine. Can you give me a better word for mathematics when we say we want to combine this and this? You add them. Now, if we wanted to do it all out, we could, and I think we should. The final, or the resultant, is what I'm going to call this. We simply take VP that we've already found, and what are we going to add to it? Good. VW. Now, I am open, depending on how far out you guys want to expand these things. Finish this together. Do you guys want to do the calculations independently? Okay, let's do it together. As I'm looking at this, we are going to rely on a bunch of calculators right now. I need to know 450 cos 300. And I'm not going to rewrite these vectors. All that I'm doing is this part here. That's the x coordinate. What is the x of the plane? Bless you. $450 cosine of 300. Well, gosh, 300 is just negative 60, so I bet it's 225.
I don't understand why, if it is giving you that the magnitude of plane, that vector
Okay.
is 450 v sub p, but then you're doing an equation to find v sub p also.
So because all they've given me was a magnitude and the direction. I am writing this out. It's the same thing. But I'm finding that, hey, out of this 450, 225 miles per hour is what I'm going
Never mind.
that direction. They're just the components. So here, I'm going to take these, and I'm not going to show the math that goes into it. 450 cos 300 is negative or positive 225? Positive. Plus 20. Because 40 cos of 60 is 20. Okay, this is how the plane versus wind combine in the air in the x direction. The y direction I cannot do as nicely. What's 450 sine of 300? Negative 389.7. Plus, what's 40 times the sine of 60? Negative 4.6. It's positive though. Okay. Okay. We have added these vectors. This is VPX plus VWX. This is VPY plus VWY. And we're just adding these pieces together. When we sum them up, I can do this one, 245. I cannot do the other one.
Also, you put VW, or wait, never mind.
Say it again?
Nope. You didn't mess up.
So, thank you, but you say yours again. Negative 424. I don't agree. You subtracted them. Negative 355.
I'm saying.
0.06. Okay. As we look at it, we have now the components of this. Okay. Are we done? Okay. Mathematically, I imagine, and if I'm wrong, please correct me, you guys can probably follow most, I hope all, of what just happened. We skipped a few steps, and you guys helped me calculate it so I didn't have to show it. But conceptually, can you tell me what we have in front of us? Like, it's obviously a vector, but what does this vector represent? The magnitude of what? Which vector? So, I agree with that, but I'm not, like, I don't know for sure that just saying that really verifies it. If we look at what's happening, we had a big vector that's 450 long, and it's going at 300. So it's going like this, right? Okay, and then the wind blows at, what is it, 60 degrees? So the wind blows and it pushes the plane like this, just a little bit. What we see is over the course of the flight, the plane that was initially trying to fly like this has been pushed that way, which we've all experienced because if you've ever had a long flight out here because you had a headwind, that's why. Like, it does impact it. And what we've identified up to here is that this x direction was how much? We're going 245 miles per hour that way. And this way, it's not to scale, but there's my negative 355. If I want to find how fast the plane actually flies, that red vector's length, how do we get it? You get the Pythagorean theorem. Or, if you don't want to have to think about the triangles, you simply say, hey, it's the magnitude of this resultant, which is, because of the Pythagorean theorem, we take that squared plus, and I would like to see you guys make this a habit. It looks like I did something wrong. Looks like I forgot the negative, right? I didn't even write it because it's such a common mistake. It's going to square itself. If you square a negative, it's going to be positive. Let's just use the positive to begin with so we don't get wonky values in our calculator. Okay, our plane. It should have slowed down a little bit, I think. I can't decide if I think, because it's blowing kind of to the north. It slowed down a little bit. That makes sense because we have a slight headwind. A little bit of this wind is fighting our south trajectory. Okay, how do we find the angle? Yeah, I have a y and an x or a sine and a cosine. I know that theta is just the arctangent of whatever the y over the x is. So it looks like it's 355, negative 355, I'm sorry, 0.06 over 245. And you are going to get me a cool angle here. Negative 55.3. Somebody seconded that value. Did you second yourself? Okay. Waiting on a second, calculatorless hands. Same thing, Fern? Feel free to speak up. Okay, so as we're looking at this angle makes sense. I'm okay with it because we're starting at the positive x-axis. It says go down 55 degrees. Cool. Our path has been changed a little bit. We have our velocity, and I'm going to write this as a bearing, and I'm going to do it the wrong way. Are we closer to east or south? This angle. So I guess rather, yeah, I'm okay with that. We're going to start at east, and we're going to turn 55 degrees, 55.3 degrees rather, toward the what? So I've heard it whispered. I'm going to start here, and I'm going to turn toward the south or north? South. This bearing drives me crazy, but it's an okay answer. Okay, I'm about to throw you for a loop. I have a completely different problem and answer on mine. And there's a reason for it, but we're not going to make this a habit. Bearings are weird just in general, right? Okay, here's the weirder part about it. For nautical stuff, you always start at north or south. In pure math, you start at the positive x-axis or east, and then you just go counterclockwise. For aviation, you start at north, and then you go clockwise. I am not going to make you guys do that. It's weird. Everybody does a different style because they, work in different fields. We're just going to work in standard position. So on mine, when I said it flies at 300 degrees, I actually had that it flies at 100 something because it was in quadrant 2. Like it's a weird little switch, but it's okay. We're just going to deal with them in standard position. Okay. This feels like physics. This is how I would like to be able to do the physics so we don't have to do all the crazy drawings and stuff, but not everybody in physics is taking my pre-calc class and vice versa. This is the simplified, quote-unquote, version where we don't have to think about the concept as heavily. But in physics, we want to think about the concept. Okay, so I was wrong. You guys get 14 minutes. And let's take a look-see. Indeed. Zeke is starting to learn the Unalaska song. So if you happen to see him and he ever says, let's go, like a silly YouTube video might, I need you guys to immediately say, Unalaska. And then his eyes will light up and he'll say it again and he's ready for golden blue. All right. So today is the 24th. We did just do applications of vectors, which is pretty cool. You guys have the privilege of working homework 6.3.3. This will be the last of it. We're going to do page 437. And let's see here. All these problems are awesome. I want to just give you the old assignment, but it's way longer than what we're doing here. Okay, I want you to do 75 through 77. Oh man, I love me some of these problems. Me? I'm always chill. 88 looks like a good choice. It's actually 428 also. Whew, that could have been bad. That could have been terrible. (103 through 106). If anybody has a textbook that you would lend me for a moment, I will get these up on the video as well. Charles, I'm going to steal your textbook. All right. So 75 through 77, 88, and 103 through 106. So here we go. Focus. All right, 75 through 77. They give you a magnitude and an angle, and they say, hey, find me the component form of this. What's the next problems? 88? Here is 88 if you're watching the video. We get three forces pulling on something. They're playing a three-way game of tug-of-war. Cool. I want to see who wins, in which direction. And then the last are lovely true or false. Are these true? Cool. Or false. And this part, justify your answer. Cool. All right. 10 minutes. You guys can knock out several of them. Sorry for the jump scare.